The question of how subatomic particles acquire mass was first theorised about more than 50 years ago. The scientists behind the theory, Peter Higgs and Francois Englert, have today won the Nobel Prize for Physics for their work in predicting the existence of the so-called God particle. ITV's Lawrence McGinty reports.
It's taken almost 50 years, but today the Nobel Prize for Physics finally went to one of science's most original thinkers.
Professor Peter Higgs at University of Edinburgh, United Kingdom.
It was 1964 when Peter Higgs predicted the existence of a subatomic particle, now called the Higgs boson. But only in July last year did scientists manage to make the so-called God particle and so prove it existed. The vindication of his theory 50 years ago brought a tear to his eye. Days after that, he was asked if he might win the Nobel Prize.
I don't know. I don't have close friends on the Nobel Committee. I haven't heard.
He'd be the first to give credit to the scientists at the world's biggest atom smasher at CERN, near Geneva, whose experiments found the particle he predicted all those years ago. Peter Higgs and Francois Englert will be receiving a Nobel medal in about 2 months' time. But it's a bit strange that the thousands of scientists at CERN who proved that the particle they predicted actually existed will get no recognition at all from the Nobel Committee. And that's because this medal can only go to individuals. After all the publicity last year, today he was shy of the cameras.
He's always been rather modest and actually looks to give other people credit where appropriate.
A modest man with a big idea that is now the bedrock of modern physics.
It's Nobel Week, a showcase of the world's best and brightest across the scientific, literary, business and humanitarian fields. This year's science contenders are particularly impressive, so impressive that the Nobel Committee has had a hard time picking who will take home the coveted titles. To discuss this and other science news making headlines, I'm joined now by AUT Professor Steve Pointing. Good morning, Steve.
Good morning, Samantha.
So we've seen Francois Englert and Peter Higgs have won the Nobel Prize for Physics. But this one ruffled a few feathers.
It did, yes. I mean, in my opinion, very well deserved. I mean, these guys theorised well over 50 years ago the existence of this particle, and I think a Nobel should be a reward for that sort of eureka moment. But the controversy has arisen for two reasons, really. Firstly, that, of course, last year the existence of this particle was demonstrated.
So this is the Higgs boson, and it's known as the God particle.
That's right, yeah. I'm not sure how PC that is, but I mean, certainly it's the particle that accounts for mass in atoms, which are the building blocks of everything around us. So it's a very exciting discovery. But, of course, the actual proof of existence was made by two very large science teams, and science these days is generally conducted by teams. So the Nobel Committee, in some ways, because they're restricted in only being able to award this to at maximum 3 individuals, they're hamstrung a little bit in who they can reward.
So thousands of scientists worked on this with the Large Hadron Collider, but it went to 2 people. It can only go to 3 maximum. Okay.
Although one could argue that the theoretical side of this particular discovery perhaps had marginally more importance than the experimental physics that actually demonstrated it.
OK, we've also got the Chemistry Prize coming up, something that Kiwis are interested in particular.
I think so, yeah. We've had 3 prizes in New Zealand over the years. 2 of them have been in chemistry, Rutherford being obviously the most famous example, and also McDiarmid, the most recent, in 2000. Chemistry prizes are interesting because they're much more open. They can be awarded for a huge spectrum of achievements. I'm not sure that Kiwis are in the running this year. But there is a very fascinating study just released about the correlation between the amount of chocolate that's eaten per capita in a nation and the number of Nobel Prizes that get awarded. So perhaps we should encourage a bit more.
So the more chocolate, the more Nobel Prizes. Oh, I like that.
Have a sweet treat today. Let's help our scientists.
Let's all have some chocolate just for the sake of that. Hey, let's have a look at this this new study released into earwax. So it's been discovered that dolphin and whale earwax could actually reveal a lot more about these mammals than we first thought.
Yeah, who'd have thought it? Poor hygiene's actually useful. To put things in perspective, this study was on blue whales, and they're the world's largest living creatures. They have very large ear canals, obviously, and the earwax plugs that these scientists studied were about 25 centimetres long, so very, very large pieces of earwax. But the great thing about this is earwax is oily, and these oils attract and preserve what we call lipophilic compounds, which include a lot of pollutants. So they form a really good record, chronological record, of what these whales have been exposed to. And they came up with two really quite startling discoveries. The first was that there's a maternal transfer of pollutants from mother to offspring, which is scary.
Yeah.
And also, well, quite worryingly, is that stress hormones are also preserved in these earwax records. And actually, during the whale's lifespan, it was shown that increased pollutant exposure was also correlated with greater stress in these animals. So that's a bit sad.
It is a little bit sad. It reminds me sort of tree bark rings, sort of something like that.
Yeah, very similar, yes.
Very quickly, new research that black carbon could be behind the end of the mini ice age in Europe?
Yeah, I mean, this has been a controversy for a long time. Climate records show us that we should have had a cooling trend well into the start of the 20th century in Europe. In fact, we have had a cooling trend, but glaciers have retreated. And it's always been a real misnomer, you know, how do we explain this? But a recent study just released this week has shown that black carbon, which is the output of industrial pollution, which was released at the onset of the Industrial Revolution in Europe, that black carbon deposit correlates very well with glacial retreat, and thus has kind of solved the conundrum of why glaciers were retreating at a time of climate cooling.
Fascinating stuff. Thanks for coming in this morning, Professor Pointing.
My pleasure.